Hi students, today we are going to understand types of chemical reaction student. That for the class 10th standard we are going to start the types of chemical reaction. And you got to know student, there are many types of chemical reactions are possible. Okay, when you talk about the first type student, that is they are the combination reaction. If you are going the very first type student, the reaction is what student? Combination reaction. Got it? And when you are talking about the second one student, so that is called decomposition reaction. And if you are talking about third one student, that is called displacement reaction. So these are the types of reaction which we have to study student, right? So let's start student from the PDF is okay. So let me check. So it is properly, it is audible and visible, dear student. So here we came. So when you discuss about type of chemical reaction student, okay, so what you are going to find in the all the cases. So let's start student. You so here something given student, a large number of chemical reactions are taking place around us every day. That is what the general statement. The chemical reaction may be different types because of the reaction involving different kind of atoms, and the way they react differ. How the atoms reacting student, that is they are going to be differ. Now thus, based on the manner in which the atom reacts are arranged, chemical reaction can be of the following 5 types they are saying student. First, combination, decomposition, single displacement, double displacement, and oxidation reduction reaction. So first of all we are going to understand student, that is the combination reaction. Okay, so let me tell you student, combination means getting combined student. The combination means getting combined. So suppose student, if anything is here A plus B and it is going to give student C. So two atoms are combining, two molecule are combining and giving one. So that is called combination reaction student. Suppose student, we are having Ca plus O2, okay, 2Ca plus O2. So it will give 2CaO. So this is what the two elements, here is a calcium element and oxygen molecule combining to give one compound. So what is the definition of combination reaction? You can read here student, they are saying a combination reaction is a reaction in which two or more reactant combine to form a compound, that is single compound. It is also called synthesis reaction or composition reaction. To understand, you can recall an activity given earlier in which magnesium ribbon, what is there student? Magnesium ribbon Mg is burned in presence of air. So it is going to burn student. So what it is going to give student? It is going to give 2 MgO to give the magnesium oxide powder. The general scheme for the combination reaction is A plus B giving AB. So they are the reactant, it is product. So Mg plus O2 MgO it is giving. Now we need to see the some other example student. What is the other example? Here you can take the example of H2. So here is hydrogen reacting with oxygen, it is giving water. So two species combining student, so giving one species, that is the combination reaction. Depending on the chemical nature of the reactant, there are classes of combination, 3 classes of combination. Okay, so what are the 3 classes of combination reaction student, that we need to understand. Here you see some example, sulfur plus oxygen, it is giving the SO2 student. Let us move here. Okay, here come. So the first one, what is there? Sulfur per oxygen. First class is what is there student? First class, if you see. So element and element combining, element combining to give compound. Sulfur plus oxygen SO2. Now the second class you see student. What is the second class? Here compound and element combining to give compound. So phosphorus trichloride PCl3 plus Cl2, it is giving PCl5. So it is compound. Similarly, here is the compound NH3 and HCl, it is going to give NH4Cl, this is compound. Some So this is what the compound and compound, this example is compound to compound, it is combining to give so either the element are combining, or the compound element combining, or the compound combining. So these things are going to be what student considered to be the combination reaction. Now if I will tell you student, that is what are the example of combination reaction. So there are many example student, what are the, let us tell you the first example student. So here is calcium oxide, that is called quick lime student, and it is reacting with the water friend. So what is calcium hydroxide they are going, this is also called lime water student, this is called lime water. Okay, so this is, now this is the two species combining to giving one, so combination. Carbon plus oxygen, it is giving carbon dioxide. Magnesium plus oxygen, magnesium oxide. Hydrogen plus chlorine, hydrochloric acid. Next one, ammonia plus hydrochloric acid, it is ammonium chloride. Quick lime plus CO2, that is calcium carbonate, that is called student limestone. This is again, it is also called student, what is called limestone student. Now let us try to move on the next one. What is the next one student? Here is the 7 number, NH3 is there and H2SO4. So ammonia reacting with the sulfuric acid, it is going to give student ammonium sulfate. So these are there. Now see student, through most of the combination reactions are exothermic. Mostly they are saying combination reactions are what student, they are going exothermic. What is exothermic student? Exothermic means heat is getting released by itself student, heat is getting released by itself. So during the product student, along with the product, what is going to be there student, heat will release student. So that is called combination reaction student, that is exothermic reaction. Now let's see students, some of them are also endothermic in nature, means that is heat is absorbed student. Endothermic means the reaction, endothermic means what student, that is heat is getting absorbed, that is called endothermic reaction student, right. So some of the exothermic and some of the what student, they are the endothermic reaction. Now let us try to understand the next one student. What will be the next one? Exothermic reaction. Here they are saying exothermic reaction, the reaction in which heat is released during the formation of product are called what student? Exothermic reaction. So they are saying that is heat is getting released by itself student. So this is what exothermic reaction student, in which the heat is released by itself, along with the product heat is releasing student. Now let us move to understand the another statement. The large amount of heat energy released on reaction of water CaO, if you touch the wall of the container, you will feel the heat. So this reaction is classified as exothermic. So what is there student? CaO H2O, it is giving calcium hydroxide plus heat. So it is called student what? Exothermic reaction. This is what? Exothermic reaction. Now let us move on the next one. Endothermic reaction, the reaction in which heat is absorbed, is called endothermic reaction. N2 plus O2, and you need to give heat student, so it will form the NO student. So it is the endothermic reaction. So I hope exothermic reaction you memorize with quick lime water, it will give the calcium hydroxide student, and here if you see endothermic N2 plus O2, it will give 2NO. Now let us move on the decomposition reaction. Decomposition reaction is the opposite of the combination reaction student. So it is also very simple student. So how can you understand decomposition? Decomposition means breaking down student. So A is there student, it can split into B plus C, or here AB is there, AB, it is the compound here, overlapping is there, this is the bond student, it is splitting, they are separating. So in a decomposition reaction, a single compound is split into two or more simpler substance student under the suitable condition. Decomposition reactions are opposite or combination reaction. Okay, so here A, B is there, so A plus B it is going. It can be also student, A can split into B plus C plus D, anything is possible student, it can split in the many of the compound, right. So now student, let us see the example we are going to understand here. So decomposition, breaking of the bond is the major phenomena in the decomposition reaction, and energy is required to break this bond, student. Depending on the nature of the energy used, the decomposition reaction, there are what classes are there? Are mainly three classes are there, student. What are the three classes? First one is thermal decomposition, second one is electrolytic decomposition, and third one is the photolytic decomposition. So thermal decomposition means what is there, student? Heat is required, heat. Electrolytic is means with what, student? Electricity is required. What? Electricity. And if I will talk about photolytic, means light is required, student. So these are the simple term. So let us try to understand, student. The first one we are going to explain you. The first one is what? Thermal decomposition reaction. So how can you explain the thermal decomposition reaction, student? In this type of reaction, the reactant is decomposed by applying heat. What you are applying, student? In the thermal decomposition reaction, you are applying the heat, student, right? Now, for example, heating mercury, student. What you are going to heat, student? You are going to heat the mercury second oxide, HgO. This is mercury second oxide. This is. So what is decomposed into mercury metal, that is Hg, and oxygen gas. So one compound is splitting into what, student? The two compound. So it is decomposition reaction. But what you are giving, student? Heat, so that the bond between Hg and O is getting big. So heat means what, student? Thermal. As the molecule is dissociated by the absorption of heat, it is otherwise called the thermolysis. You can call it thermolysis also. It is class of compound to element decomposition, that is compound HgO is decomposed into two elements, mercury and oxygen. So this is what the decomposition. Now let us have a look over the one activity, student, demonstrating the thermal decomposition reaction, student. How can you demonstrate? Activity 1.5 from the NCERT book, student. So dear student, what you are doing here, you are taking calcium carbonate, student. What is the formula of calcium carbonate? CaCO3. You have taken in the test tube, student. This is the tube, and you are heating, student. From the here you can see that you are heating. So you are heating, it will give the CaO plus CO2, student. So one compound is splitting into CaO plus CO2. So this is what is going to be what, student? That is thermal decomposition reaction, student. Now students, this is what the endothermic or exothermic, student. So this is going to be what, student? That is going to be what? Heat is required. Now this is the endothermic, friend. This is the endothermic, because heat you are giving, heat you are supplying. How can you test the CO2 form, student? This CO2, if you are passing this CO2 in the lime water, student, this is CO2, na, student, CaOH whole twice, this is called lime water. You pass the CO2, student. So it will give the CaCO3, okay, it will give CaCO3 plus H2O, and total solution will become milky, student. So you can test for the CO2 also. So here you see, student, in the above activity, on heating calcium carbonate decompose calcium oxide and carbon dioxide, student. So this is what the thermal decomposition reaction, student. Now let's try to move out the next one, student. What is the next one here? See, they are saying calcium oxide, also known as lime, okay, more especially quicklime, is a white, grayish white solid produced in the large quantity by roasting of the calcium carbonate. Calcium carbonate means CaCO3. You are roasting means heating. So it will give CaO plus CO2. Now calcium carbonate comprises more than 4% of the earth crust. This is the 4% there in the where, student? Earth. It is how much? 4%. It most common natural form of the chalk, whatever we are writing on the board, student, that is, it is common. Limestone and marble produced by sedimentation of the cell of the small fertilizer, nails, shellfish, coral over millions of the year. This is millions of the year. So these were the answers. Now here is one more activity, is demonstrate the effect of heat on lead nitrate. So lead nitrate, what is there, student? PbNO3 it is twice. So if you are heating this student, taking 2 molecule, so it will give student NO2, how many student, 4 NO2, plus PbO student, how many, 2 PbO, plus O2. So this will, so it is also the decomposition reaction. You heat it student, you will get the brown color student, brown color gas is evolved. It means this is the NO2 gas is released student. So this is very simple student, I am not going in much detail. The brown fumes are the nitrogen. So more examples of the thermal decomposition reaction. There are many examples of the thermal decomposition reaction student that we are going to explain you. What are the examples that we have to understand student? So dear student, when you talk about the example of thermal, so here is the first example is ferrous sulfate student, ferrous sulfate. So this ferrous sulfate is going to decompose on heating student, it will convert into ferric oxide student, SO2 and SO3. So ferrous sulfate it is converting into what student, 3 compound, ferric oxide, sulfur dioxide and sulfur trioxide student. So this is what. Now let us move on the potassium chloride, KClO3 student, heat you are giving and catalyst MnO2. So it will give student what, KCl plus 3A2. So this is also the thermal decomposition. Zinc carbonate is there student, you give the heat, it is give ZnO plus CO2. Next one is electrolytic decomposition student. We have to understand what do we mean by electrolytic decomposition. So when you talk about electrolytic decomposition friend, so here you see electricity is required. In case of electrolytic decomposition, electricity is required. So it is the what student called electrolytic decomposition reaction student, right? So here see, in some decomposition reaction, electrical energy is used to bring about the reaction. For example, on passing electricity through water that is acidified, decomposition occur into hydrogen gas and oxygen gas. The decomposition of sodium chloride occur on passing electric current through its aqueous solution. Sodium chloride decomposes into metallic sodium and chlorine gas student. This process is called termed as electrolysis student. Okay. So this is how we are dealing student. Wait student, let me check that is the whether it is working on the internet or not. YouTube, just I want to see student, is it working or not? Okay, that I have to see. Okay, it is quite working. Here you see student, lead nitrate is white crystalline solid. It is soluble in water and non-combustible, but it will accelerate the burning of the combustible substance. If large quantity of material are involved in the fire, an explosion may occur. So this is the lead nitrate they are saying, that is lead nitrate is the white color. Up now here the experiment what they are saying, that is the demonstrate the process of electrolysis. So what we are doing is student, we are taking the water here and passing the electricity. So what the gas you are getting is student, H2O is if you are decomposing student, passing the electricity. So what will happen here friend, it will give the H2 gas, 2H2 gas and plus O2 gas. Okay. So H2 and O2 gas will be liberated student. Okay. Some more example we are going to discuss student. Wait, I have to check why it is. Now aluminum Al2O3 is there, passing the electricity student, it will convert it to aluminum and oxygen student. So this is the Al2O3. Second one here 2NaCl is there student, pass the electric current student, sodium and chlorine it will give. So this is what the electrolytic decomposition reaction. Next one we are going student, photolytic decomposition reaction. Photolytic means what is the sunlight is required student. What light is required student? Sunlight. So here the light is another form of energy which facilitates some decomposition reaction. For example, when silver bromide is exposed to light, it breaks down into silver metal and bromine gas. As the decomposition is caused by light, this kind of reaction is called photolysis student. What reaction is called student? the reaction is called student photolysis. So when light means what student? Light means, okay, light is the form of the photons. In the term of the light, what is coming student? Photon is coming. Suppose this is the radiation student. So this radiation is sunlight is composed of the energy packet. These are the energy packet student. This energy packet is called photons, and from this name it is knowing to be a what student? Photolysis. Let us try to understand student. Demonstrate the decomposition reaction. What kind? Photolytic decomposition. So silver bromide is there student, AgBr. You see the AgBr student, complete white color, and if you are giving the light student, which light student? Sunlight. So it will give Ag and Br2 student, right? So take the two molecule here. This is the quite grayish color student. So here you see silver bromide decomposed to silver and bromine when kept under sunlight. The light yellow colored silver bromide turn into gray color due to sunlight. The activity show decomposition reaction of silver bromide. What kind of decomposition student? It is the thermal decomposition. Similarly, AgCl also you can do. Now we are going to understand student displacement reaction, right? Let us try to understand student displacement reaction. So what is the displacement reaction student? If I will ask you explain the displacement reaction, so how can you explain the displace? So here you see student, one element is there and here is the compound is there. So this is going to displace student B. So B is getting removed and a compound forming is what student? AC. So one element displacing the other, that is called displacement reaction student. So more reactive element displaces the less reactive element student. So this is what is called student displacement reaction. They are the reactivity series student. You can see potassium, sodium, lithium, calcium, magnesium, aluminum. So this is the most reactive. Here you can see at the top it is the most reactive: zinc, iron, lead, hydrogen, copper, silver, gold and platinum. So at the end what is there? Platinum, gold and silver. Why they are going to use as the ornament student? Because the reason behind this, they are non-reactive. So if they are not reactive, there is no attack of atmosphere, so easily they can be used as a ornament. So this is what the answers. Here you come to student, here they have given the displacement reaction activity. What is there student? Here is copper sulfate. You are adding the iron nail student, silver color iron nail. This is the iron nail. Then what is the copper color? Color of copper sulfate, blue to it is converting into the light color student, okay, and this is the what they totally they are the nail is going to be corroded student. So iron displaces the copper. Here see iron displacing the copper from the copper sulfate. So FeSO4 and Cu is forming student. So next one you see student, what is the next one? Demonstrate the reaction between zinc dust and HCl. So you know very well zinc is the more, this is the non-metal displacement reaction student. So zinc if you are treating with the HCl friend, so two molecule you take student, it will give the ZnCl2 plus hydrogen gas. So it is the non-metal displacement. Hydrogen gas is getting liberated student. This is the non-metal. So this is the non-metal displacement reaction student. This is the non-metal displacement reaction. Now let us move on the next one student. What is there? There are many activities are there student for the displacement reaction. Consider the example, zinc treated with H2SO4, it is going to give student ZnSO4, and here is the hydrogen gas is liberated. Zinc is treated with the copper sulfate, it is going to give student what the it is going to give? It is going to give student zinc sulfate and copper. Lead nitrate treated with the zinc student, zinc nitrate and lead will be out. So these are the what is called student, here is the displacement reaction student. They all are the example of the displacement reaction, right? Here is the chlorine. Now see student, here chlorine treated with the KBr, so it is forming KCl and bromine is the out. Similarly chlorine is there, Na is there, so it is forming NaCl and I2 student. So these are what student? These are the displacement reaction. Chlorine displaces the I. So here is I, here bromine. This is sodium and water, so NaOH, and here is hydrogen gas displaces, student. Now some more example, you see iron and copper sulfate, you have seen ferrous sulfate and copper is going to be formed, student. Here you see aluminum and copper sulfate, aluminum sulfate. Okay, this formula is not correct, student, it is the Al2SO4 whole thrice, student. This is, and copper out, copper plus silver nitrate, AgNO3. Here is the copper nitrate and Ag is obtained, student. So these are the displacement reaction. Next one is, student, you see magnesium and copper sulfate, student. So if you are seeing this is magnesium and copper sulfate, so it is forming magnesium sulfate, and here is copper, and copper here you see, student, aluminum sulfate treating, no reaction. Why? Because this is the copper is less reactive, student. So less reactive metal cannot displace the more reactive metal, student. Ag is, it is also less reactive. So less reactive metal cannot displace the most reactive metal, student. So this is, next one you see, student, double displacement reaction, double displacement. So double displacement means what, student? Ions gets exchange, ions gets exchange, student. So ions gets exchange each other. This is what is called, student, double displacement reaction. Let us try to understand. When two compounds react, and if their ions are interchanged, then the reaction is called double displacement reaction, right? The ions of one compound are replaced by the ions of other compound. Ions of identical charge are only interchanged. That is, a cation can replaced by the other cation. This reaction is also called metathesis reaction, the scheme representation of double displacement. So AB plus CD, so AD, it will form AD and CD. So this is what the scheme for the double displacement reaction, students. So this is, here if you see, student, one example they are saying, so Ki solution is there, student, white color, and PbNO3 there. So it is there, it will form KNO3, student. So that is what the K is displaced by Pb. Okay, so here it will form PbI2 also, PbI2 and KNO3. So KNO3, this will be formed, the student. So here you see, here you see, student. So PbNO3 lead nitrate treating with the 2 Ki. So PbI2, it will form, the student, precipitate, and KNO3 will form. This reaction is double displacement reaction. If two reactants exchange their constituent ion chemically and form the product, the reaction is called the double displacement reaction. Now let us move on the next one. For double displacement reaction to take place, one of the product must be precipitate. Means it will form the solid compound, student, like the barium sulfate, it is precipitate, student. Silver chloride, it is precipitate. What they are saying, based on the product formed, there are two major classes of double displacement reaction: precipitation reaction and neutralization reaction. So double displacement reaction are going to be how many types, student? Two types. What is the first one? Precipitation, and second one is neutralization. We are going to understand precipitation reaction, student. What do you mean by the precipitation reaction, student? Here the insoluble solid substance form, student. The double displacement reaction in which two ionic compound react to form an insoluble product is precipitate, and the reaction is called precipitation reaction. Precipitate, that is PPT, is the insoluble product formed in aqueous solution. Some example of precipitation reaction are what, student? What are the example of precipitation? Reaction of aqueous barium hydroxide with the aqueous sodium sulfate result in the formation of precipitate of barium sulfate. So barium chloride and sodium sulfate treated. So BaSO4 is the precipitate, and NaCl will be in the form of aqueous, student. Similar, silver nitrate is there, NaCl, so it will give the precipitate of AgCl. Now neutralization reaction. What is the neutralization reaction, student? If you talk about neutralization reaction, this is also called acid base reaction. In earlier classes you have studied about this reaction between acid and base. a type of displacement reaction in which an acid react with a base to form salt and water called neutralization reaction. As both the acid and base neutralized each other, reaction of the sodium hydroxide and hydrochloric acid belongs to the category of neutralization reaction. Here sodium replaced hydrogen from hydrochloric acid, forming sodium chloride, which is the neutral soluble. So NaOH is there, HCl, so it will forming NaCl and H2O. Some other example you see student displacement reaction, double display, calcium hydroxide CO2, so calcium carbonate H2O, AgNO3 NaCl, so AgCl student NaNO3, CuSO4 ammonium hydroxide Cu copper hydroxide and ammonium sulfate, AlCl3 ammonium hydroxide, AlOH whole thrice and NH4Cl. This is some more example you can see here on this page student. What are these example? Copper sulfate and H2S. So CuS H2SO4. You can make a note of it student. Sodium hydroxide HCl. So sodium is displacing the hydrogen. So it will form the NaCl and H2O. Here is sodium again displaces hydrogen. So Na2SO4 and H2O. K is displacing hydrogen, so KClH2O. Here is the NH4 is displacing hydrogen, so NH4Cl. NaOH means here is the student sodium is displacing the acetate, sodium is displacing the hydrogen. So sodium acetate and hydrogen is going to be formed student. Now let us move the next one student. What are there? There are many activities are there student. Here is redox reaction we are talking student, redox reaction. The redox reaction is type of the reaction student that is called the oxidation and reduction reaction. Any reaction student, reaction in which oxidation and reduction reaction taking place together student, that is called the redox reaction. Okay. The reaction in which oxidation and reduction reaction taking place together, that is called student what? Redox reaction. Got it student? So student, an oxidation reduction reaction is an chemical reaction in which the oxidation number of molecule, atom, ion changed by gaining or losing electrons. We can also define oxidation reduction in terms of gain or loss of oxygen and hydrogen. So redox reaction are common and vital to some of the basic function of the life, including photosynthesis, respiration, combustion, corrosion, rusting. So these are the example of the redox reaction student. So let us try to understand with the help of example how it is going to be defined on this page student. So redox reaction, it is made up of two reaction, oxidation and reduction. So the RED means reduction, OX means oxidation. Oxidation means loss of electron and here is reduction means gain of electron. Now go little, increase in positive charge, decrease in negative charge is oxidation, decrease in positive charge and increase in negative charge is reduction. So if a substance gain oxygen, losses hydrogen during the reaction, it is called oxidized. Okay. So here you let us try to understand with the example. Here you see student, KCl is there. Up KCl student, here is the charge is 0, here is 0, but here is the plus 1 and minus 1. So student 0 to plus, so this is called student oxidation, positive charge increases, and here is 0 to negative student, so that is called reduction student, because positive charge decreases. Similarly ZNO you see student, here is plus 2, minus 2 and 0. Here is 0 student, here is the plus 2, minus 2. So zinc plus 2 to 0 student, plus 2 to 0 means reduction, and here is student minus 2, here carbon 0 to plus 2, this is the oxidation student. So these are going to be what student? Redox reaction. Let us see H2S student. So here is the plus 1, minus 2, 0. Here is what student? Plus 1, minus 1, 0. So sulfur minus 1 to 0. So this is what? Oxidation. And chlorine 0 to minus 1. This is what is called a reduction. Right student? So this is what the concept. In the next video, student, we will going to understand the rancidity and corrosion we will study in the next video, student. So thank you very much for watching, students.